This is the review on triangle congruence and proofs with triangles, also exterior angles theorem and Triangle Sum Theorem. This is Module 15 Part 1. Goes from lesson 15.1 all the way to 15.3. Good luck all of you on your test. I hope this helps. Okay, we're going to start with number 1. Now, on number 1, you want to make sure that these three angles, angle A, angle C, and angle B, are all adding up to be 180. So we obviously do not know what angle B is. So we are going to set up an equation, x plus 30 plus 35 equals 180. That's the triangle sum theorem. Okay, since 30 plus 35 is 65, we're going to take 65 and subtract it from both sides. And we will end up with x equals 115. So x is really the measurement of angle B. So the measurement of angle B is 115. Okay, we're done with number 1. Number 2, same idea. This is 90. We don't know f. X plus 90 plus 20 equals 180. X plus 110 equals 180. Subtract the 110 on both sides. X equals 70. On number 3, all of these three angles are actually equal. We don't know either one of them, so we'll call them all x. There's 3 of them, so 3x, and it's still a triangle. They all add up to be 180, still triangle sum theorem. Divide by 3 on both sides, and that means x equals 60. Well, angle G equals 60, angle H equals 60, and angle I equals 60. They're just asking me for G. It's 60. Number 4. This is the exterior angles theorem. We do not know L. That's the one they're asking us for. Okay, these two angles, L and K, x plus 65, are equal to the outer angle, which is 130. Subtract 65 from both sides. And x equals 65. Now x is the measurement of angle L. That means the measurement of angle L is 65. On number 5, you can tell that Q is congruent to angle T. You can also tell that angle R is congruent to angle U. And that leaves us with angle P congruent to angle S. Now we're looking for the measurement of angle P, but we know that it is equal to the measurement of angle S, and we know the measurement of angle S. Yay! So the measurement of angle S is 35. That means the measurement of angle P, which is our answer, is also 35. Number 6. This is the exterior angles theorem once again. We know that angle Y and angle X equal the outer angle. This one here, which is the one they're asking us for, V, W, Y. We don't know that one, so we're going to set up an equation. X, which is our red angle, equals the two green angles, which is 40 plus 80. And that means we now know x, which is the angle we were looking for. And we know it equals 120. And that is our answer, 120. Number 7. For number 7, we need to use the polygon sum theorem, which says that I can multiply 180 times n minus 2. Now, I know the number of sides is a quadrilateral. A quadrilateral has 4 sides, and that means that is my n value. 4 equals n. If I plug it into my formula, 180 and 4 minus 2, I'm going to get 180 times 2, which that means my answer is 360. Done with that problem. Number 8. The angle measures of a triangle are A, 3A, and 5A. Tell the measure of each angle. Well, we know that A plus 3A plus 5A altogether equal 180. Because it is a triangle, and triangles, interior angles add up to be 180. Now, 1A plus 3A plus 5A equals 9A. So that means 9A equals 180. If I divide by 9, A is equal to 20. With that 20, I can now use it to find the measure of each angle. My first angle measures just A, and A is 20. That's my first angle. My second angle is 3 times A, so 3 times 20, which is 60. And my last one is 5 times A, which is 5 times 20, which is 100. And that's all the angles. Now, if you add up 20 plus 60 plus 100, it should add up to be 180, which it does. Let's go to number 9. Okay, on number 9, we're going to start with our first congruence mark, which is FE. We're going to go across to the angle across, that's angle D. We're going to start with our second congruence mark. We're going to go to cross also, and that's angle E. We know that the measurement of angle E is actually equal to the measurement of angle D. And we are looking for angle D. This is our goal. But we actually know what angle E is, which is 50. So we can replace that 50 there, which will give us the measurement of angle D. And that gives us our answer of 50. Number 10. Again, isosceles. You know that there's one congruence mark, leads you to angle S. So we know that the measurement of angle S is going to equal to the measurement of angle U. Now, we actually do not know either one of those two measures. So I'm going to mark them with X each one. I don't know them. I know I have 2 X's. So 2X plus the 50 that I know should add up to be 180. Okay, so now I can subtract 50 from both sides. We'll end up with 2X equals to 130. If we divide by 2 on both sides, then we end up with X equals 65. That means that the measurement of angle U, which is one of the X's, is 65. Okay, that concludes page 1. Page 2. Let's start with number 11. This is an equiangular triangle, which is also at the same time an equilateral triangle. If all of my angles are congruent, then so are my sides. That means that I now know that 5t is actually equal to 40, and I can set up an equation. So 5t equals 40. Divide by 5 on both sides, t equals 8. That's all I needed to know. Number 12. Write the angles of angle DEF in order from smallest to largest. My smallest side is 1.14. 1 and 1/4. Across from that side is angle F. So that means that the measurement of angle F is actually smaller than the next one, which is 2. 2 is smaller than 2 and 1/8, but it's also bigger than 1 and 1/4. So across from 2 is angle D. So that would be the next one, measurement of angle D. And that's smaller than our last one, which is 2 and 1/8, which is the largest side. But across from it is the largest angle, which is the measurement of angle E. We have listed the angles from smallest to largest. Let's go to number 13. On number 13, they're asking us to write the sides of the triangle GIH in order from shortest to longest. So we are going to start with finding out the measure that's missing. X is I. X plus 59 plus 61 equals 180. Okay, so X plus 120 equals 180. Subtract 120. X equals 60. So the largest angle is 61. Across from it is side GI. So this is the largest. The smallest angle is angle 59. Across from that is side IH. So this is the smallest. And they want me to go, or the shortest, they want me to go from the shortest to the longest. So our shortest is IH. You can put commas, or you could do the inequality. The one in the middle is the one that's not marked, which I'll mark in yellow, which is GH. And the one that's largest is the red one, which is GI. Number 14. Can 3 segments with lengths 8, 15, and 6 make a triangle? For this problem, you need to choose 2. So I'm going to choose 6 and 8. You could choose any 2. It really doesn't matter which 2 you choose. You're going to take your 8 and your 6 and you're going to subtract it, bigger number first. And then you're going to add them. And you're going to see what you get on both of these. So my first answer is 2. My second answer is 14. And I want to check to see if I can make a triangle out of this. I want to see that 15, the one that I didn't choose earlier, is actually a number between 2 and 14. And no, my answer for this is that this triangle cannot be made. So this triangle cannot be made because of the triangle's inequality theorem. Number 15. A polygon has an interior angle sum of 2,520. How many sides must the polygon have? Show all your work. So we know the polygon sum theorem says that I need to have 180 times n minus 2. Now that should give me my interior angle sum, which is this, my interior angle sum. And they actually gave me my interior angle sum. So It's supposed to be giving me my interior angle sum. But I was given this number, which is 2520, so I need to substitute it right here. So I'll end up with 180 n minus 2 equals 2520, and that's an equation I need to solve in order to find what n is. To solve that, I'm going to divide both sides by 180. So I end up with n minus 2 equals 14. Now all I have to do is add 2. And I know that my polygon is going to have 16 sides. So the answer is 16 sides. My number 16 is an exterior angle theorem problem again, which means that I can add the r with the s, add those together, and they should equal the 6x. So set up your equation, which we end up with 6x equals 77 plus 2x plus 3. 6x equals 77, 80 plus 2x. Subtract the 2x on both sides. 4x equals 80. X equals 20. Well, we now have x, but we need to take that x and substitute it here because they're asking us for the measurement of angle S. So all I care about is angle S. Show your work. So we're going to substitute. I want to say 2, and we're substituting something for x there. And we have our x, which is 20. So 20 times 2 is 40. And 40 plus 3, that means the measurement of angle S is equal to 43 degrees. For number 17, we need to count how many angles we have. I found out we have 6 in red. So I need to use my polygon sum theorem again. I need to subtract the 6 minus the 2. And I will end up with 720. So that's my magic number. That means I need to equal all of these angles to 720. To make my life easier, I added up all the blue angles, which I ended up with 607. I added the x so that I could start setting up the equation, and I used my green number from up above, 720. Now, if we subtract the 607, then we'll end up with x equals to 113. And that's all they wanted. They wanted us for us to solve for x. We're done with number 17. Number 18 is asking for the same thing, for you to solve for x. On number 18, we have 5 sides or 5 angles. So when I use the formula, I'm going to use 180 times 5 minus 2, which turns out to be 540. First, add the 7x, 8x, 6x, 10x, and 4x. That turns out to be 35x. Then add the 4, 3, 8, negative 4, and 4, which turns out to be 15. And set it equal to the 540 from up above that you found earlier, and solve that equation. After subtracting 15 from both sides, we end up with 35x equals to 525. And after dividing by 35, x equals 15. We have solved for x. Number 19. This problem is asking you to find the measure of each numbered angle, which means that they want the measurement of angle 1, they want the measurement of angle 2, they want the measurement of angle 3, and they want the measurement of angle 4. You can use angle 58 here, the measurement of angle 58, and the measurement of angle 2. Those two should add up to be 180. If we subtract 58 from both sides of the equation, that means the measurement of angle 2 is 122. That means that we now know the measurement of angle 2. Since angle 2 and angle 3 are vertical angles, all vertical angles are congruent, which means they have the same measure. So that means measurement of angle 3 is also 122. Since we know the measurement of angle 2 and the measurement of angle 3, we can use the Triangle Sum Theorem to find the measurement of angle 1. So the measurement of angle 1 plus 122 plus 22 equals to 180. If we solve that equation, we're going to find out that the measurement of angle 1 is equal to 36. Next, we need to find the measurement of angle 4. So the measurement of angle 4 plus 122 plus 20 equals 180. And that would mean that the measurement of angle 4 equals 38. And we found all 4 angles. That concludes page 2. On to page 3. Number 20 has an octagon that's 8 sides. So if I want to find out how much the interior angles add up to be, then I would have to put 8 minus 2, which turns out to be 1080. We'll use that number in a bit. The next thing you need to do is add up 120, 165, 95, 110, 135, 50, and 55. And don't forget that that's only 7 angles. So you have another angle that you don't know, which is the 8th angle, and that one is x. So all of the given angle measures add up to would be 930. So I set up an equation, x plus 930 equals 1080 from the green above. Once we subtract 930 from both sides, we find out that x is equal to 150. And that's the missing 8th exterior angle, 150 degrees. Number 21. Find the measure of the exterior angle shown. So they want you to find the exterior angle, which is 3x minus 22. We know that 3x minus 22 equals the 2 remote angles added together, so x plus 80. Solve the equation. So we will subtract x from the right side, moving it to the left side. We're also going to add the 22, moving it from the left side and over to the right side. That's going to give us 2x is equal to 102. Once we divide by 2, we find out that x is equal to 51. But they also want us to find the measure of the exterior angle, so we're going to need to substitute this 51 into our exterior angle. That's going to give us 3 minus 22, and in here we're going to substitute our x, which is 51. And we find out that the exterior angle measures 131. Number 22 is also an exterior angles problem. Same thing. We're going to set up our exterior angle, 6x minus 7. Set it equal to the 2 remote angles, which are 2x and 103. 103 minus x. We're going to solve that equation. If we combine like terms, 2x minus x, 2x minus x becomes x. And now we're going to solve that equation, moving the x over, and also adding the 7 to the other side. This gives us 5x equals to 110. X equals 22. Now we're going to have to take our new x and substitute it into the exterior angle. So 6 parentheses minus 7. Plugging in our 22 that we just found, we find out that the exterior angle measures 125. Problem number 23. Since triangle BCD is an equilateral, we also know that all the angles measure the same, and since they're all 180, if we divide by 3, each one is 60. So this will help us when finding out the measurement of angle ABC. By the way, we're looking for angle ABC. In triangle ABD, we have an isosceles triangle, and we now know that angle 66 is across from one of the congruent sides. The other congruent side is across from angle D, so we also know that this is also 66. That'll help us find our missing angle X. 66 plus 66 is 132, so we can set up an equation. X plus 132 equals 180, since it is a triangle and we know all the angles add up to be 180. If I subtract the 132 from both sides, then I know that X is equal to 48. So that means we now know this angle here, and we need it in order to find the measurement of angle ABC, because ABC is both of these numbers added together. So it's the measurement of angle ABC is going to equal to 48 plus 60, which adds up to be equal to 108 degrees. We found our answer. Problem number 24 has DE congruent to FE. We have another isosceles triangle. If we mark from one congruent side to the angle that is across, we know that angle E measures the same as angle D. And angle D has a measurement, which is 4x plus 1. So both of these angles measure the same. Now I could set up an equation with the Triangle Sum Theorem, which says that all the interior angles of a triangle sum to be 180, which would mean, for me, that I need to add my 4x, my 5x, and my 4x over here. That's going to turn out to be 13x. Next, I need to add all the numbers, which is 1, negative 4, and 1, which becomes negative 2. Then I need to set that all equal to 180. Solve that equation. 13x equals 182, and x equals 14. Okay, since I need to find the measurement of angle E, I'm going to use the 4x plus 1. And since I know what x is now, I'm going to write in my 14 here. And I find out that the measurement of angle E is 57 degrees. On numbers 25 through 27, I need to decide if I have enough information to prove that the triangles are congruent, which means they have the same shape and size. If there is enough information, then I need to state the congruence postulate that will help me do that. The congruence postulates allowed are side, 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 angle, side, angle, side, angle, 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 side. And the congruence postulates also hypotenuse lay. Okay, the congruence postulates not allowed, the ones that we do not allow are angle, 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 and side, side, angle. These are not allowed. Number 25, we have a side here that is being used by both triangles that we can say is congruent. So if we look here on the triangle, you can see that you have an angle, you have a side mark, and now you have another side mark. If you can see now, you have side, a side, and angle, but this is one of the ones that are not allowed. So this would mean that the triangles are not congruent. On number 26, we also have a side that's being shared by both triangles. That means we can mark this as a side. We have an angle that's being shared by both. So far we have side in green, angle in red, and the angle is next to both sides that we're looking at, which is also marked. So that's a side. So we have the angle in between both sides. That means that we have side, angle, side. So that means these triangles are congruent by the side, angle, side theorem. Number 27. You can see here that we have side AC, which is congruent to side EC. That's one side. So we have a side. Next, we have angle ACB and angle ECD. That's an angle. And next, we have the side BC, which is marked with 2, and that's congruent to CD or DC here, so that's a side. So these triangles are congruent by side, angle, side. On number 28, we need to complete a proof. First of all, they told us that LA is parallel to SN. That helps us gain alternate interior angles. So that means I can use angle LRA, angle L, and angle N. Those are going to be congruent. I also have vertical angles in the middle. So that's angle LRA and angle NRS. If you look at the picture, we have angle, side, angle. So that means our triangles are going to be congruent. And that's all we need to do is prove that the triangles are congruent. That'll prove it, angle, side, angle. So now we have to just state our reasons. We know that LA is parallel to SN because it was given information. We didn't have to think that through. Angle L is congruent to angle N because the lines were parallel and because they are alternate interior angles. So it's the alternate interior angles theorem. Okay, next we know that LR, which is a side, is congruent to NR because it was marked on the picture and it was given. I believe this is a typo here, so that should have been congruent. So it was given information. Didn't have to think that one through. And angle L, LRA, and NRS, though that was not given, but we know that vertical angles are all congruent. So this is the vertical angles theorem. And last, we know that the triangles are congruent to each other by the angle, side angle from up above that we planned out. Number 29. Given information is angle A is congruent to angle D, and it's already marked on our picture. Next piece of information that they gave us is that AC is congruent to DC. That is also marked up above in the picture. And they gave us the clue that we have vertical angles. So our vertical angles are here in the center. So I have to mark it with twice instead of once. But I do have to name them, and this is a shared vertex, which means this point here in the middle is being shared by both triangles and both angles. That means I cannot just name it angle C. So I'm going to need to name the angles A, C, B, and that should be congruent to angle D, C, E. Next, we can look on the triangle here, and we can see that we're going to use angle, side, angle. So we're going to have to name the triangles. We can use the angle from step number 3 to just turn it into triangle. ACB is congruent to triangle DCE. And last, we needed a piece of the triangle. So now that we know that the triangles are congruent, we can take this piece of information that we need, which is they wanted us to prove that BE is angle B is congruent to angle E. Here's angle B. And angle B and E were not marked before, but because we know the triangles are congruent to each other now, we now know that any piece will be congruent also, and the piece that we need in this case is angle B congruent to angle E, and that's the last step in our proof. And of course it's by corresponding parts of congruent triangles are congruent. That concludes page 3. And finally, page 4. Number 30. These two triangles are congruent, and we did need to change this to 4y instead of 4x because they are asking us to solve for x and y, and that was a typo there. So we know that we need to find x, and x is the angle F. So we know that angle F is actually congruent to angle I. And at angle I have 53 degrees. So angle F has 2x plus 7, and angle I has 53. So if we solve that equation, we find out that x is equal to 23. The next equation has to do with finding for y, or y, finding y. Now, we find y at ji. So if you look on the triangle, ji is congruent to gf. So ji is congruent to gf just by following the letters that they gave us for congruence. And I know that gf is 32. So I'm going to set up this equation for y equals 32. So 32 divided by 4 is 8. So that means y is equal to 8. We're done with that problem. Number 31. On number 31, you're going to need the Pythagorean theorem, which says that c squared is equal to a squared plus b squared, which means we're going to need a right triangle somewhere. Across from the right angle is our C side, that's our C. And on the two other legs are A and B. Okay, so I'm going to end up using this triangle here since since this triangle has the x in it. Now, they did tell me that this whole side at the bottom is 10, which to me, and also they marked it that these two pieces are congruent. So that means this piece is congruent to the blue piece. Okay, those two pieces are equal to each other. That means that this piece is 5, and so is this piece. And then one last piece of information is the fact that they told you that this side here is 12. So now I have a triangle that looks very similar to the one that I have up here. And I have 12 here, 5 here, and x at C. I can substitute my numbers. So C is x, so x squared. A is 5 squared. And B is 12 squared. If I use the calculator, x squared equals 25 plus 144. So x squared is 169. And the opposite of a square is a square root, so I need to do that to both sides. So x squared 169. The square root and the square will cancel, leaving me with x. And the square root of 169 on your calculator is 13. So we have found x. Number 32. The measurement of angle 1 is congruent to the measurement of angle 2. Measurement of angle 1 is congruent to the measurement of angle 2. They were not marked on your picture, so I'm marking them. Lines L and M are parallel, which means I can mark that as well with an arrow. These two are running in the same direction, and they are constantly the same distance apart from each other. For the given information, angle 1 was congruent to angle 2, that was given, and the linear pair postulate says that when you have a linear pair, then they are supplementary. So that would mean that the only linear pair I see is 2 and 3. So if you look here, it looks like this, 2 and 3. That would mean that these two angles are adding up to be 180 degrees. But I'm going to say angle 2 and angle 3 are supplementary. Now, if they are supplementary, then that means they are adding up to equal 180. So we can actually write that the measurement of angle 2 plus the measurement of angle 3 equals 180. Now, since angle 1 and angle 2 are actually congruent to each other, I can replace angle 2 with angle 1. And that was substitution. And lastly, since angle 1 and angle 3 are adding up to be 180, and they are same side interior, and since I'm trying to prove that the lines are parallel in this step, I cannot just say same side interior. I would have to say the converse of the same side interior angles postulate. Number 33. They're asking us to find the joint relative frequency. So the joint, when you're trying to find the joint, you're going to use these numbers and the 200 at the end. So we need to find out where someone likes classical and pop at the same time. So if you look at the graph, yes, they like classical. Yes, they like pop at the same time. It's going to be 82. So it's going to be 82 over 200. And if we change that into a percent, the 82 goes in your calculator first, then you divide by the 200. That gives you 0.41, and if you turn it into a percent by multiplying by 100, it becomes 41%. Okay, for the marginal frequency now, for the marginal, those are going to be your margins. That's going to be these numbers and these numbers. Also, again, divided by the 200. So we're going to use those. And this time they're asking us to find the marginal relative frequency of people surveyed that like classical music. So all the total people that like classical music is 97. And we're going to put that 97 over the 200. And that's going to turn into 0.485, which if you multiply that by 100 turns into 48.5%. Part C, they're asking us again for another marginal, which is going to be the edges again. But this time we want the marginal frequency of people surveyed that actually like pop music. So the ones that like pop music, yes, total of 124 people who like pop music. So that's going to be 124, again over our 200 grand total, which will turn into 0.62. And again, if you multiply that by 100, it'll turn into 62%. Number 34 is another exterior angles theorem problem. Okay, so we have the exterior angle, which is 160 degrees. And we need to add angle D and angle E together. So measurement of angle E plus the measurement of angle D equals 160 degrees. In the problem, they tell us that the measurement of angle D is 3 times the measurement of angle E. So they're really telling us something about the measurement of angle D, but they're telling us nothing about the measurement of angle E. That makes our measurement of angle E our X. And what we know about D is that it is 3 times whatever E is. And E is X now, so it's 3 times X. So we know that the measurement of angle E is X. We know that the measurement of angle D is 3 times the measurement of angle E, which is X. And we know that the exterior angle is 160. So now we can solve this equation. X plus 3x is 4x, and it equals 160. And x, if we divide by 4, is equal to 40. So now we can find both measures. The measurement of angle E, which is just x, so it's 40. That's one answer. The measurement of angle D, which is 3 times x, which is 3 times 40, which turns into the measurement of angle D being 120. So that's our second answer. That takes care of page 4. I really hope that all of this helped you and that you do excellent on your test tomorrow. I hope your grades improve because of this, and enjoy. Thank you. Make sure to get plenty of rest and eat a good breakfast. And I hope that you enjoyed the help that you got from this video. Thank you.